Have you ever paused before a slice of tuna and thought, wait, this can't be fish? It's crimson, rich, and glowing like molten steel, more like beef than anything that swims. While most fish wear pale, delicate colors, the tuna stands apart, bold, radiant, almost royal. It's the movie star of the ocean, gliding through darkness with the confidence of a predator that knows it's built differently. But here's the twist. That deep red color isn't just beauty. It's biology's rebellion against one of nature's oldest rules. Fish are supposed to be cold-blooded, except this one isn't. What if I told you this creature carries a miniature nuclear reactor inside its body? A self-sustaining furnace that lets it blaze with energy beneath the freezing sea. The tuna isn't just a fish. It's a living engine. A hot-blooded marvel of evolution, burning with purpose and power beneath the waves. Beneath that sleek metallic skin, the tuna hides one of evolution's greatest engineering feats. A miniature nuclear reactor inside a tuna. No, it's not a metaphor. It's biology at its most brilliant. Inside the tuna's body lies a structure called the rete mirabile, Latin for the wonderful network. This tightly woven system of arteries and veins acts as a heat exchange engine, a biological masterpiece that lets the tuna do what almost no other fish can: stay warm in cold water. Here's how it works. Most fish lose body heat the moment their warm blood passes through the gills, where it meets icy seawater. But the tuna has hacked the rulebook. Its blood vessels are arranged side by side. Warm blood flowing out of the muscles sits right beside cold blood coming in from the gills. Instead of wasting energy, the tuna recycles it. Heat flows from the outgoing blood into the incoming stream, molecule by molecule, keeping that warmth inside. Imagine two pipes, one carrying hot water out, one bringing cold water back. Wrap them together, and the warmth transfers perfectly. No heat lost. That's exactly what happens within the tuna's body. Warmth changes everything. For a tuna, heat isn't just comfort. It's performance. Every extra degree means faster reflexes, sharper vision, and stronger muscles. When its body runs hot, the tuna's muscles contract with machine-like precision, firing again and again without slowing down. That's how it can chase prey for miles without rest. Its brain and eyes are kept warm, too, allowing it to think and see clearly in the cold, dark depths, where other fish slow down or go blind. In the open ocean, that kind of control is everything. Speed, strategy, survival. The tuna doesn't just swim. It dominates. That's why scientists call it the athlete of the sea. Every heartbeat fuels its propulsion system, each flick of its tail, a burst of power refined by evolution itself. And when it moves, the ocean parts like silk. It's not just swimming. It's slicing through time, chasing life itself. Now, let's decode that mysterious red flesh. Inside every slice of tuna lies a secret weapon, a molecule called myoglobin. Myoglobin stores oxygen in the muscles, tiny biological tanks that keep every cell breathing even during long, relentless motion. The more a muscle moves, the more myoglobin it needs, and the redder it becomes. That's why chicken breast is pale, it barely moves. But tuna, swimming non-stop through the ocean, turns deep crimson. Each slice of tuna is a map of endurance, a story of muscles that never rest. Understanding this biology changes how we cook it. Tuna isn't like most fish. Its meat behaves more like beef. That's why chefs sear it fast and hot, caramelizing the surface while keeping the inside pink and tender. On that sizzling surface, something magical happens. The Maillard reaction. Sugars and proteins collide, breaking down and rebuilding into hundreds of new aroma molecules. The chemistry of flavor itself. That smoky, meaty scent rising from the pan, it's chemistry. Delicious chemistry. And that dark line of meat near the spine, the one chefs often trim away. It's the part that worked hardest. Packed with myoglobin and fat, it carries a bold, iron-like flavor. Some call it too strong. Others call it the soul of the fish. And this is just the first chapter in the encyclopedia of tuna. The secrets of how to age fish to enhance umami, or how to recognize a piece of otoro that cries when sliced, are another story, perhaps told in Foodchemy's master classes. Do you prefer to eat tuna cooked like a steak or fresh sashimi? Let Foodchemy know your thoughts in the comments below.